Hi, welcome back. This is video 3. Now we're going to go over questions 10 through 15 and 17 and 18. Not a lot of room there. So again, I'm going to put this on another piece of paper and then you could just staple it together with your assignment. So question 10 states a balloon with a circumference of 17. So the formula for circumference is 2 pi r. And it says that the circumference is 17. So where the letter C is in the formula, they said that I can substitute for 17. Now using the circumference, approximate the volume to the nearest centimeter. So let's set this up. The 2 pi is keeping r from being by himself on one side. So I'm going to divide both sides by 2 pi. And this goes away. And so we get r is equal to 17 over 2 pi. Now they've asked me to approximate. So I'm actually going to keep this in exact form. I could turn it into a decimal, but then I'd have to try to hold it in my calculator. So I'm just going to leave it like this. And then again, the volume of a sphere is provided for us. 4/3 pi r cubed. So the volume of a sphere would be taking all this stuff, which is what I think r is, and then cubing it. So whatever I end up thinking it is, I think it will work out nicely. Whatever it is in my calculator, I'm going to multiply it by itself 3 times in a row, then multiply it by pi, multiply it by 4, and divide by 3. So this is really difficult only by calculator. You've got to make sure you type it in here right. So let's get my radius. My radius is 17 divided by 2. Enter. So that's 8.5. Divide by pi, enter. So this is the big ugly number that I think is my radius. Now they said whatever the radius is, so I can rewrite this if this makes people feel more comfortable. The radius is 2.70 ... It's a big number. Keeps on going. Now I need to cube that. So on this type of calculator, I can hit this button, take that to the power of 3, hit enter, and that's this number cubed. So that's 2.70 times 2.70 times 2.70. There we go. We get 19.80. And again, I still have to multiply it by pi and multiply it by 4, and I can't forget to divide by 3. So let's multiply it by pi, enter, multiply by 4, enter, divide by 3, enter. Okay, so the volume they've asked me to approximate to the nearest centimeter, okay, would be 83, to the nearest centimeter would be 83 centimeters cubed. And again, I could double check it by working back through the problem. Now let's go to question 11. Now again, a lot of these are harder than you'll see on a test, but great experience for what it might be like closer to the midterm or on the final. Okay, so volume 11 says volume of a sphere with a diameter of 14 pi. So if the diameter is 14 pi, and it says leave your answer in terms of pi, the radius would have to be 7 pi. So again, if the diameter is 14 pi, the radius would have to be 7 pi, and I can find the volume of a sphere. This formula is provided to you. Still, these are a little bit harder than the test, but great practice. So my radius is 7 pi, and they said leave my answer in terms of pi. So in the numerator, I have 4 times pi, and I have 7 times 7 pi times 7 pi times 7 pi. Wow, a lot of pi's. And then I need to divide by 3. So if I focus on the numbers 4 times 7 times 7 times 7, then my answer would be 4 times 7 times 7 times another 7, 172 divided by 3. If I divide by 3, I get a decimal. So I'm going to leave it like that. And I actually have pi to the 4th power. Technically, that would be my answer in terms of pi. Centimeters cubed. The reason why I have 4 pi's is I started with a pi in my formula, and then they told me to cube the pi. Lots of pi's. And that's a little tricky, but again, nothing that hard on the test, just good practice. Now it says volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. And the volume of that sphere, so where you see the letter V, you can put 5,000 pi. Okay, now they'd ask us to solve to the radius to the nearest meter. So 4/3 pi r cubed. I like how this one ends up because I can divide both sides by pi. I notice that all of this stuff is keeping r from being by himself on one side. So I'm going to divide by pi on both sides. Rewrite the question. 5,000 is equal to 4/3 r cubed. Okay, now using a little algebra, notice I can multiply by the reciprocal. To get this to go away, I need to divide by 4 and multiply by 3. So to get rid of a fraction, you can multiply both sides by the reciprocal. That's a trick from middle school that is very helpful. And so now I can rewrite the problem. It's 3 times 5,000, so it's 15,000, divided by 4 equals the radius cubed. So let's see what we get. 15,000 divided by 4 is 3,750 radius cubed. So now it's the to the power of 3 that's keeping r from being by himself on one side. So I actually need to take the cubed root. And how I do that on this calculator is right there. And we'll do this later on in the year. So this is some good practice. So if I want to take the cubed root, I hit second y to the power of x and tell it I want to take the cubed root, enter, and I get my answer, and they said round to the nearest meter. So I'd have to round 15.5 to 16 meters. There we go. Now question 14 states, every plane section of a sphere will be A. So I think most students would get this right. Every single plane, whether I cut it vertically or horizontally, is going to be a circle because it's made by stacking circles that are getting smaller. What solid forms when you revolve a line segment that starts at the origin about the x-axis? So let's see what that would look like. When you revolve a line segment that starts at the origin around the x-axis. So let's just say this is our line segment. If I revolve it around this x-axis, I think this is similar to a problem we've seen before. Anytime you take a line and you swivel it around another line, it looks like I'm going to get a cone. All right. Questions 17 and 18. What 3D do you get when you rotate? So this is like the poster in my room. When you rotate a triangle, right off our notes, you spin a triangle, you get a cone. You spin a rectangle, you get a cylinder. And right off the poster, you spin a circle, you get a sphere. So those are important to know. Now, last question. It says, list the 2D shape you get with a vertical. So this is right off of our notes. What do you get with a vertical cross section? So our notes said that shadow puppets help us picture vertical cross sections. Shadow puppets help us picture vertical cross sections. Okay, so a right cylinder in a shadow puppet, so I'll call this one A, B, C, D, E, and F. Okay, so a right cylinder shadow puppet would be a rectangle. A right cone shadow puppet would be a triangle. C. A sphere shadow puppet would be a circle. D. A right rectangular prism would be a rectangle. E. A right triangular prism would be a rectangle because the triangle would actually be sitting on the base. So I actually wouldn't be able to see. I would only see the rectangular faces of my prism. So that's going to be a rectangle. And F, a right rectangular pyramid. Well, pyramids in shadow puppets look like triangles. There we go. I answered my last question, question 18. Good luck studying. Thanks for joining us. See you Monday or Tuesday.